Okay, cool. So just talk about number 6 really quickly on the homework. So what I would do is this. I would say I kind of work backwards, like x equals plus or minus 3i. So therefore, x squared equals 9. Do you guys see how I got that? Because if I square both sides, actually I take it back, not 9, -9. Because that's why you get the I. Therefore, this comes from x squared plus 9. That's where it comes from. So I'm just working backwards. Same thing over here. X would equal 1 plus or minus I root 2. X minus 1 equals plus or minus I root 2. Then x minus 1 squared. And that would be -2. Because if you square root -2, you do get root 2, but the I with the negative. Then if you FOIL, you get x squared minus 2x plus 1 equals -2. Or x squared minus 2x plus 3 equals 0. Then you actually FOIL these two together, and you get your final answer. There we go. So I'll do that in red down below. Yeah, come on. Right? So you have x4 minus 2x cubed plus 3x squared plus 9x squared minus 18x plus 27. If you combine it, you should get x4 minus 2x cubed plus 12x squared. Does it make sense what I'm doing? Yeah. So that's a bit labor intensive. I mean, it's good to know how those answers came about, where they came from, what factors it came from. I think that's kind of good. The whole foiling between these two guys, I mean, I'm kind of torn about that. That seems like busy work in my personal opinion, but I'll talk to the pre-cal teacher to see what they have in mind, because what we're going to design a test next week. And if I look at the answers, yeah, that's what you get. So wait, plus 18. What? Hold on. Did I make a mistake somewhere? I got plus 27. That's weird. Did I do something wrong? But you have I root 2. I'll have to look at our answer because I don't. Yeah. No, that doesn't make any sense, because that should be yeah, she left out the 1 because there's a 1 there. No, her answer's wrong. Mine's right. I'm right, guys. I know I am. Okay. So, and lastly, 7. Yeah, if you just think about it, it's just going to be x equals plus or minus root 11. So clearly x squared equals 11. X squared minus 11 equals 0 is one of the factors. X minus 1 is another factor. And you FOIL those two. Do that correctly, you should get x cubed minus x squared minus 11x plus 11. That's a pretty straightforward one. Yeah, not that hard. Okay. All right. So I think that covers the homework. So here's what I want to do. I want to briefly talk about this classwork. I might be jumping the gun a little bit because I actually should do a lesson on this, but let me just do a couple problems with you guys, just to make sure you guys kind of see what's happening here, because this is give you a taste of what we're gonna do on Monday. And honestly, after I finish these 2 problems, you guys can just chill, because I know you guys are totally exhausted. I honestly don't know why we have school. That's just between you and me. The day after Rock Job. You guys are here from like 8, 9. What time do you guys leave here? 1:30. 1:30 in the morning? Oh wait, no. No, you're partying? No. Dude, you need some coffee. So I've been here 19 years. I could joke about this stuff. Anyway, what time do you guys? What time does it over on campus? 9:30, guys. That was Rock and Jock. Yeah. But anyway, you guys been here. You guys had a long day yesterday, so so just a couple problems. You guys want to relax after that's totally fine. Okay, we'll leave it at that. You don't need to. I should be at the end of the packet. It should be right at the end. It says classwork number 12. Okay. So it looks like we're actually are going to be asking you guys to turn this in. So this is because we're actually going to, I think, finish off with this unit. Start with this section. Let me just double check that we don't have another one on deck. Let's see here. Yeah, we don't have another. This will be our last section. So we're gonna I'll definitely talk about two problems here. Yeah, it looks like she has this plan for the end of next week. It's okay, I'm jumping the gun a little bit. But we will talk about 7.8 on Tuesday, wrap it up on Wednesday. Friday will be a review day, and another review day after that, and then test. We'll actually get 2 review days, okay? And I'm going to give you guys a quiz. The quiz, I'm actually going to put it on Tuesday also next week. So the quiz will be on 7.4 to 7.6. Will be like on synthetic division, other stuff like that. So anyway, be on the lookout for that because I'll put that in Schoology later today. It'll be on Tuesday. But let's talk about this stuff here. Here we go. So you guys are here? You guys are there? Right? Okay. So when you graph these, we did do this in Algebra 2. I know we did it, but we did it in probably a lighter fashion, not as complex as this. So I'm just going to do 1 and 2 and then kind of stop there. So when you do graph these are pretty complex things. This is probably one of the most complex things in there. It's called a rational function, right? We have 2 polynomials, the ratio of 2 polynomials, right? And this table is really helpful. We'll actually have this table on the test because you want to make sure, I mean, just for my own sanity, my grade is like, hey, I don't want to like to search for your X. That's all right work. Just put it right here. Put the verb down to the horizontal. We'll talk about oblique means, poles, line step, domain, and range. And then we use all this information to do the graph. So first off, always, always, always factor. Factoring is a big deal. You really want to factor this as much as you can. Now, when it comes to factoring, there's a couple ways, not a couple, there's more. It's kind of up to you how you want to factor. Do you guys usually do this in a box? Have you guys done this before? Yeah, let's do that. So let's look at the top one. Do you guys remember how this works, how this process, what are you supposed to do? Like you have 3 and -5. You're supposed to multiply those two. And then -14 put down below. Do you guys remember what to do next? Find 2 numbers that do what? Multiply and add. Good. And what are those 2 numbers? Perfect. Good. -15 and 1. So what this enables us to do is split the -14. The -14 gets split into 2 numbers, -15 and 1, because courses add up to -14. So what I do is I write 3x squared in here. I write -5 in here. And I put these 2 guys over here. Whether the -15x goes in the bottom left or top right doesn't matter. And the x goes top right, bottom left doesn't matter. But I usually put the 3x squared in the top left and the -5 in the bottom right. And your goal is to find factors along each row. For example, what can I factor out of the first row between 3x squared and x? Then this has to be 3x, right? Because what you're trying to do, they call us like bathroom tiles. This times this, x is good. Then we multiply 3x to get down to this guy. 3x times what? This and this. And guys, -5, yes, exactly. And then we're rolling, right? Because then this has to be a 1, and there you go. 3x plus 1 and x minus 5. And if I do it for the other one, and don't worry, the second problem I'll do is a factor for us, so it makes life a little easier. That's going to be -16. What do 3 and -16 multiply to? -48 in the middle. Okay. I'm going to have to dig a little deep on this one. Do I know what this one is? Maybe. Yeah, I do. Yeah. Okay. Yeah, 12 and -4. Yes. Yes. -4 and 12. Yes. So negative 4x and 12x. What can I factor on the first row? Yeah, and then that would be x. Then this has to be negative 4, and this has to also be, sorry, positive 4. Okay. Does that make sense?
The factoring part. So you guys spent lots of time factoring, right? Like, you know, I mean, I know. Actually, it's crazy. I think the pandemic killed us. I think we started Zoom school. I think tomorrow was the 4th year of this or something. I remember this was Monday, March 16th. Yeah, I remember. I'm pretty sure it was 14. It was 14? Yeah, 16. Okay, maybe forget. Well, anyway, it's on this time, right? So, but you guys are doing this stuff in middle school, right? You guys are in middle school and everything. So, you know, hopefully you guys are connected with these help factors. Yeah. So we have factors. The reason why we want to factor is to do this stuff easily. For example, an x-intercept.
An x-intercept was when y is 0, right? Because y equals all this junk. That's when y is 0. So if I replace the left side here with 0, now think about it. You have a fraction.
One has to be true for a fraction equals 0. The top or bottom has to be 0. So, yeah, the bottom I don't care. The bottom actually be something else. That's a vertical aspect. The top has to be 0. So the top is 0, and you get what? Well, then 0. So what makes each of these 0? Well, what makes that one 0? 5. And that one's negative 1/3. Those are x-intercepts.
That's going to help with the graph. So negative 1/3 and 5. You can run them as ordered pairs if you want, but I mean, you know you're going to cross the x-axis at those two locations. Now the vertical asymptotes. The calculus teacher and me, and we have a calculus teacher in back as well. There's actually a very formal way of thinking about it. I'm just going to kind of give you the quick and dirty way, just because you guys are tired. Just make the bottom 0. You make the bottom 0. But the more formal way, which I'll just briefly say,
is that you want y to go towards positive and negative infinity when you have vertical asymptote. When you have vertical asymptote, you have those like little dashed lines, and the graph kind of goes haywire and gets close to it. The reason it goes haywire is because
as x gets close to a particular number, y is shooting up or shooting down forever. This is actually called an infinite discontinuity because it's a break in the graph, the discontinuity part, infinite because y is going towards positive negative infinity. I need to have a greater discussion about that with you guys on Tuesday. For now, just make the bottom 0. So that's 4/3 and negative 4. And they're equations, by the way. They are equations. They're vertical lines, so you write like this. Okay, oblique asymptotes, I'm going to cross that off. That's not applicable here. I'll explain what that means in number 2. Poles, I'm going to cross that off. I'll explain what that means in number 2. The y-intercept, just plug in 0 for x. I'll get back to horizontal asymptote in a sec. For y-intercept, just plug in 0 for x. If you plug in 0 for x, what are you stuck with? Yeah, or 5/16. That's right across the y-axis. Domain range is going to be all real except the asymptotes. So it's from negative infinity to negative 4, negative 4 to 4/3, and 4/3 to infinity. Okay, that's going to be the vertical asymptote. Sorry, the domain, because you have to exclude the vertical asymptotes. The range we'll come back to later. Best to do at the end. Now the horizontal asymptotes, you may not remember this. I know it's y equals 1. I'll explain why. Let me erase this here. And we have to have a great discussion of this on Tuesday. The reason why it's y equals 1, you have to focus on the leading terms. Yeah, totally. Yes, good, Jack. Leading terms for both the numerator and the denominator. So if you think about it.
So all horizontal ever is, by the way, it's an end behavior. What is the left end doing? What is the right end doing? Or maybe that's your right and my left there. What are both ends doing, right? Well, when you go further to the right, what's true about x? X is large, right? We're going further to the left, what's true about x? It's this negative large that makes it a negative million, negative million. Well, if I put in, like, say, 1,000 for x, you're squaring, and then multiplying by negative 15, and then just have negative 5. Here you're squaring, and 8 times 1,000 minus 16. Here's the deal. the x squared dominates all the other terms. It's squaring, but an x gets larger, these two numbers are negligible compared to what that is. This doesn't matter. So you really just focus on leading terms. So if you focus on that, all the other terms don't matter when you're looking at horizontal asymptotes.
So you're looking at 3x squared with 3x squared. What does that reduce to, guys? That's why it's 1. It's not exactly y equals 1, but it looks like it. When you graph it, the graph's going to look like a horizontal line when you go forward to right and forward to the left. There's actually something called like a limit, which I'll have that discussion on Tuesday with you guys. And we'll talk more about on Wednesday as well. So basically when the degrees are the same, you take the ratio of their coefficients. Now, what if I had this instead? What if I had like 3x squared or 3x cubed? So if I look at that, if I replace this x squared with x cubed, that reduces to 1 over x. As x gets larger, what does that reduce to? If you have if you have 3x squared with 3x cubed and reduce that, 1 over x, as x gets bigger and bigger and bigger, what does that fraction go towards? 0. It gets smaller, exactly. So it just, yeah, so in that case, it would be 0. And then if you have this kind of case here, if that were 3x cubed, that becomes x. As x gets bigger, there's no limit then. Hence, no horizontal asymptote. Instead, we have something called an oblique asymptote. We'll cross that bridge later. So you take all this information and you make the graph. Now, in the interest of space, I'm going to actually do my graph off to the left. You guys could do it down below, but I don't want to move this table here. So I'll do a few tick marks. All right. Gotta do a few more. Just realized that. Five, negative 1/3, y equals 1, negative 4/3. Negative 4. Y-intercept is 5/16. All right. Now, usually what I'll do is I'll do a sign chart right below, kind of an overlay. Oh boy, I messed up, guys. One of the asymptotes. My apologies. Where did you guys see where I messed up? Yeah, my apologies. It happens. And I caught myself as I was doing the sign chart, which is good. It's like an extra layer of protection, right? Nothing wrong with that. It's like getting extra insurance for your powerhouse. So here we go. Okie dokie. So why do I do a sign chart? Because I want to see whether the graph is positive or negative, or above or below the x-axis. Or sorry, if y is positive or negative, or if the graph should be above or below the x-axis. So for example, if I were to plug 6 in, right? And remember what I had as my factor form. My factor form was 3x minus 1, no, plus 1, x minus 5. And remember I had 3x, what was it again? 3x minus 4 and x plus 4. Is that correct? Yeah. Yeah, so if I plug in 6, for example.
everything's positive, 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 positive. So everything's positive.
And because every factor was linear, I'm going to see an alternation in signs. So I expect the graph to be positive in the far left. So it'll be kind of like this. I expect graph to be negative until we get to negative 1/3. So probably kind of like this. Then it's positive for negative 1/3. And then it's going to actually do this, something kind of funny like that. And it's negative until you get to here. And it goes like that. I know it's kind of weird.
Can I cross? Sure. Some people think you can't. I don't know why. Actually, I do know why.
Because it's taught wrong. Because you're usually taught simple rational functions and those don't cross, and then you feel like it can't cross ever. I know no math teacher says that here, but it's a misconception that I think just curriculum-wise messes you guys up. I get it. But you can cross horizontal asymptotes. It's really only about the far left, far right. The vertical asymptotes you can't cross because then you make the bottom 0. That's a problem. And why can you cross the horizontal asymptote? The reason why you can cross it is because if I were to set the equation equal to 1, right? Actually, I would get a valid answer for x, right? If I were actually to solve that, right, multiply both sides by the bottom and solve for x, I would actually get a valid answer for x. And so it's fine. There's not a problem with that. It's totally okay. In fact, actually, I think I would get 12x equals 21. I get like 1 point something, which looks like I do. So that's how the graph would look. Okay. We'll do one more, and then I'm done. And then you guys just relax and enjoy Quiz Bowl. It is Quiz Bowl, right? Yeah. Okay. This is factored for you. This is factored for us. So this is easy. 1, -3, and 5. X equals -2. X equals 4. There's not a horizontal asymptote. I'll explain why in a sec. There are no holes. I'll explain why. The domain's going to be all real except -2 and 4. So you write like this. By the way, I didn't do the range for the previous one. It was all real numbers. So always do the range last. Sorry, I didn't do it for the last one. It's all real numbers. This one we'll worry about after I finish graphing it. Y-intercept, plug in 0 for x. That's 15 over -8. Okay. Just plug in 0 for x. A little more tricky because it's factored. Now here's the issue with horizontal asymptotes. If I were to FOIL it, which gosh, I really don't want to do, you get x cubed up top, you get x squared in the bottom, and a bunch of junk afterwards. The problem is that if x gets really big, the top gets much bigger than the bottom ever would, so it never levels off. Instead, an oblique asymptote is like a slant asymptote. Only way I could help me to make sense of this, like, I mean, I don't really work out, but like you have your oblique muscles, they seem kind of slanted, if that helps. I don't know if that helps. But it's a slant asymptote. So it's an asymptote that's actually slanted, not flat or horizontal. I let a huge sigh because in order to do, you have to do long division. I know. It's not a fun. Let me do it really quickly. I'm recording this, so I do have to fold the bottom, which is this. The top, if I foil it, you guys don't have to copy because just watch. It's fine. Well, we're gonna do this again on Tuesday. Then I have to FOIL again, which is x cubed plus 2x squared minus 3x, and then -5x squared, -10x plus 15. So it's x cubed minus 3x squared minus 13x all over all this junk. Then you have to do long division. So yeah, this is where long division comes back to the vengeance. And it does come back in calculus too, actually. So you have to do this, all this jazz here. Because the whole point is to see what will x approach, so what will y approach as x gets really big. you would have to multiply the leading term by x to get to x cubed. So you get this. You might remember this from a couple weeks ago. You subtract. That becomes negative x squared and negative 5x plus 15. Then you have to multiply by negative 1. And you get all this junk here. I know. Plus 2x plus 8. Yeah, I've already gone down this rabbit hole. So you have that. So that's your remainder. I think I've done that correctly. Now here's the deal.
This fraction, when x gets big, this fraction vanishes. Why does it vanish? Because it's not as low as the bottom. So that just, so this answer is the same as this. It's just really big way. These are actually the same thing. This is cosmetic change. But the reason why we do this is to see, oh, when x gets larger, this just vanishes. So the end behavior is x minus 1. So the graph actually looks like
like a linear function on the far left right. It actually looks like x minus 1 when you look at, like, if you were to draw x minus 1, draw the graph, you almost see an overlap between the two on the far left and far right. So that's the oblique asymptote. So you actually draw a dashed line following that equation. That's what you do. Unfortunately, you have to do long division to find that answer, which kind of sucks. It's a very labor intensive process. We'll do this again on Tuesday. Don't worry. We'll do it again. No, because it goes away. That's the whole point. You want to see what it would reduce to when x gets really large. So if I do the graph, I'll do the graph off this side here. And I have a few tick marks. We'll do 6 tick marks on each side. 4, 5, 6. Negative 2, 4, x minus 1, so that's your slant asymptote. Y-intercept is at like roughly negative 2. We have the vertical asymptotes. Okay, now I do a quick sign chart. 1, 2, 3, 4, 5. So that's 5, 4, 1, negative 2, and negative 3. If I put any number larger than 5, say 6, everything's positive, and all the signs will alternate because all of them are linear factors. So I expect the graph on the far left to do this. It's going to be tucked away like this here. Sorry, not tucked away. It's going to be like that. And then it's positive between negative 3, so it shoots up between negative 3 and negative 2. Then it's negative until it hits 1. Then it's positive until it gets to, so it kind of does that. And it's negative before it gets to 5, and it does that. That's how the graph looks. The range is all real numbers, by the way. It's like the previous problem. You can always plug in Desmos, find it for yourself. But the sign chart, I'm a really big fan of the sign chart. I'm not sure why I should put that there.
But I think it really helps you determine. You can go to those sign out fully. Sometimes, yes, you can. Yes, you can. Yeah, if you were to actually set this equation as less minus 1 solid, you'd actually find the next value where it touches. Absolutely. It's only for the far left. The far left is the equation like this myself. The far left is equation like this. That's what we're playing. It's actually called an end behavior asymptote. So,
all right, that was a little more than I hoped to cover with you guys the morning after Rocket Truck. So at least I talked about it. Maybe we'll remember some stuff on Tuesday. But I feel like at least I had to do something with you guys. So anyway, we'll do a deeper lesson of this on Tuesday. Okay, you guys just relax, enjoy the morning. All right, I'll stop.